So dear students, before we start this video, you must have ready in your hand a book of log tables in which 4 digits accuracy is there. That is log table with 4 digits. You must keep it in your hand ready before you start watching this video. In between, when I say a pause, you must stop the video for a moment and try to calculate the things yourself using the log table. So let us study how to use log tables and anti-log tables, which are to be used both in physics as well as in chemistry at +1, +2 as well as at higher levels of study. So log tables are meant for solving complicated calculations in which the powers could be fractions, could be in decimal form. You can easily calculate the complex calculations using logarithmic and anti-logarithmic tables. So I hope you will enjoy this video. Let's start. So first of all, what do we mean by log of a number? If a raised to power b equals c, then we can write log of c with base a equals b. So b is exponent. We mean to say to what power a should be raised to in order to get c. If a is raised by power b, then answer turns out to be c. The things will be more clear with following examples. Like 10 power 3 is 1000. We can write it as log of 1000 with base 10 equals 3, which means log of 1000, that is 10 raised to power should be what in order to get answer equal to 1000. So that is the meaning of log. Another example, log of 2 with base 10 is equal to 0.3010, which means if I raise 10 to the power 0.3010, then the answer is going to be 2. Another example, log of 2 with base 10 equals 0.3010 means if I raise 10 to the power 0.3010, the answer is going to be 2. Same way, log of 20, that is what should be the power by which 10 must be raised in order to get 20. The answer is 1.3010. Please, you need not bother how did we get 0.3010. That is going to be obtained using log table. The part before decimal, like 0 here, 1 here, is called characteristic. How to get it? The method is just count the number of digits in the number whose log is to be taken. If the number of digits is 1, then 1 minus 1 equals 0. If digits are 2, then 2 minus 1 equals 1. The second part after the decimal, that is 0.3010, is called mantissa. It would be obtained from the table. Further, what you would notice in the discussion, log of 2 or log of 20 or log of 200 or log of 2000 all will have same value of mantissa, that is 0.3010, which means in the log table you won't have 2, you won't have 3, because mantissa for 2 and 20 are same. Same way mantissa for 3 and 30 would be same, 4 would match with 40 and so on. So our log table would begin with the first value equal to 10. because 1, 2, 3, 4 are not required. Instead we must see, instead of 2 you should go to 20 straight away. For looking 5, just straight away go to 50, and so on. Okay, now how to see the characteristic from log table? Another example, log of 3 with base 10 equals 0.4771. Now let's go to the table, how to manage the mantissa part. Dear student, now open the page on which logarithms is written. Logarithms. Here the firstmost column written with 10, 11, 12, 13, 14, 15 and so on. These two digits represent first two digits of the given number. For example, if number is 107, then first two digits are 10 and second digit is 7. So this part 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it corresponds to your third digit, and again it begins with 1, 2, 3, 4, 5, 6, 7, 8, 9. This part corresponds to fourth digit. So if your number was recently we were saying log of 2, I told you 2 wouldn't be available here, you would straight away go to 20. So in front of 20 we are given 3010. Hence log of 2 is 2 minus 1, characteristic is 0, and for 2 and second digit 0 we have seen 20. In the second column, 20 in the column of 0 was 3010. So we didn't have any third digit. That is why we are seeing the second column, that is below 0, what is written in the row of 20. So 20 would have characteristic equal to 0.3010. Same way log of 20. 20 has two digits, 2 minus 1 equal to 1, and again 20 is to be seen in the second column, that is under 0. So again you would get 0.3010 as mantissa. Now what about log of 3? 3 again has one digit, 1 minus 1, 0. Hence characteristic is 0. To have mantissa, look, instead of 3 we must switch over to 30. 30 has mantissa 4771, that is log of 3 should be equal to 0.4771. Now let us go to some bigger numbers like log of 5. So where should you see log 5? Log 5, correct? Log 5 should be seen in the row of 50. So here it is 49. So go to next page. 50 as seen under 0 is 6990. So mantissa for 5 is 0.6990, whereas number of digits again 1, 1 minus 1, 0. Same way log 7, you must try yourself. Pause here, see yourself. So check whether you get 0.858451. Next digit you must try log of 238. How many digits? 1, 2, 3. Characteristic should be 3 minus 1 equal to 2. To look for mantissa, see 23 under 8. 23 in the column of 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 3766. So 2.3766. Next you should try log of 431.5. In case a decimal is involved, just count the number of digits before decimal, that is 1, 2, 3. So characteristic again is going to be 2. 3 minus 1, 2. Now you must look 43 in the column of 1. Then in the last 9 columns under 5 also. Now see what is to be done. The number was 43, first 2 digits, third digit 1, fourth digit 5. So first locate 43 under 1. 43 under 1. It is 6345, and your fourth digit is 5. That means 43 under 1, 6345. Add to it. This was under 1, under 2, under 3, under 4, under 5. In the row of 43, we are getting 5 under 5 in the column of 5. So add this 5 to 6345. So you get 6350. So characteristic is 3 minus 1, 2, and mantissa is 6350. So try to do it yourself. Next part, log of 1.732. Now pause here and try to do it yourself. Number of digits before decimal 1, 1 minus 1, 0. Look 17 under 3. Then in the last part under 2, add the 2. Check whether you get this answer. Again, number of digits before decimal 1, 1 minus 1, 0. See what is written in the row of 17 under column of 3. Then at the end in column of 2, just add the 2 and check the answer. Is it matching? So let's proceed further. There are few rules for log tables. Log of A into B. We are not using base 10 here because now it is understand once log is written, log of something is always with base 10. So you may simply write log instead of writing base also. So keep in mind log of A into B equals log A plus log B. Like log of 45 into 29 is log of 45 plus log of 29. Now try to do it yourself. Whether you get log 45 and then get log 29, just add the 2 and pause here and see whether you get this answer. Same way. Next rule is if there is a division of two number quotient, log of A upon B, in that case this plus would change into minus. So it becomes log A minus log B. You may try another example. Log of 23 by 4. Pause here. Try log 23. Then find log 4. Subtract the 2 and check whether you get this answer. Again, last rule. Log of A raised to power B. So what you have to do, bring this B as multiplier. B times log A. For this you can try log of 5 cube, which should be equal to 3 times log of 5. Pause here and check whether you get this answer. Another exercises are, just see the question and pause the video, then match your answer. So log A into B is to be applied. Log 20 plus log 32, add the 2, get the answer. Another exercise for division, log of 195 by 47. Check. It should be log of 195 minus log of 47. Pause here, see yourself and try to match the answer. Same way, the case of exponent, try this one, log of 29 raised to power 0.4. First bring 0.4 here, find log 29 from the log table, multiply the answer with 0.4, check and match your answer after you pause the video. So this was all about how to take log of a number. So we have learned how to see log of a number. Antilog is just a reverse of the logarithm. So now we'll find how to use anti-logarithmic tables. If log of c with base 10 is b, it otherwise meant log b, that is antilog of b, is equal to c. Antilog means the exponent is given. You are required, if 10 is made power equal to b, what is going to be the answer? So that again requires the next table, that is called anti-logarithmic table. How to get 10 raised to power something is called antilog. So antilog of b equals to c means if 10 is raised to power b, the answer is going to be c. So for example, we had log of 20 in the last slides. 20 had two digits, 2 minus 1 1, and mantissa for 20 was 3010. So we already obtained this answer in the last portion. Log of 20 was 1.3010. So if I take antilog of 1.3010, I must get 20. So both are opposite of each other. So 10 power 1.3010 would be equal to 20, which otherwise can be said as antilog of 1.3010 equals 20. Now how to see it? How do we get equal to 20? So just go to the anti-logarithmic table, that is the very next page. So you have to go to page of anti-logarithms. The first two digits here in the very first column, they show first two digits of mantissa. Like in the current case, our mantissa was 0.3010. So 30 are the first two digits, 1 is the digit number 3 and 0 is digit number 4. So we must again see anti-logarithm table. So first of all, see where is 0.30 written in the firstmost column. 0.30 is here. Then we have to see it under 1. So 0.30, third digit is 1, under 1 is equal to 2000. Could you look at it on the table? So it means antilog of 0.3010 is 2000. 2000. After that, this 1 would decide where to place the decimal. So 1 means just add 1 more to it, because now we are discussing anti-logarithm table, which is opposite of the first one, that is logarithm. In logarithms we had reduced the number of digits by 1. In anti-log, just add 1 more to the characteristic, that is 1 plus 1 2, then leave 2 digits from the front side, 1 2, place a decimal here. But since the last 2 digits were 0 0 only, so you need not write. So log of 20 was 1.3010. So antilog of 1.3010 is 20. Let me show you again. 0.30 under 1 0.30 under 1 was 2000. Since 1 plus 1 characteristic was 1, 1 and 1 2, just leave 2 places from the front side, 1 2, place a decimal here, so it becomes equal to 20. Now let's try another one, antilog of 2.1116. So what you are supposed to do now, check in antilog table what is written in row of 0.11 and in column of 1 first. 0.11 in column of 1, it is 1291. Just add to it the fourth digit, which is 6. .11 under 1 was 1291. Then under 6, 1 2 3 4 5 6. So this 2 has to be added to be here to make it 1293. 1293. Now where to place decimal? 2 plus 1, that is 3 digits. So leave 1 2 3 digits and place decimal here. In the same manner, you should try antilog of 0.7552. Pause here, do it yourself and check the answer, whether your answer matches. Try another one, antilog of 3.5689. First 2 digits in the table 0.56. Check what is written under 8. Then go to the very last column, what is under 9 in the same row. Add the 2. Now where to place the decimal? 3 plus 1, leave 4 digits. You already have 4 digits, 1 2 3 4. So place decimal here, you need not place. So answer is 3705. Last one, try antilog of 2.2011. Pause it, check yourself. So see whether your answer is 158.9. I think you have learned how to use both the tables. So how to solve questions using log tables now. So let's have a question. Find the value of 45 raised to power 2 by 5. So first we'll assume y is equal to, or any other name you can give, z, x, anything. So let y is equal to your given number. Take logarithm on both sides. Left hand side log of y, right hand side log of your given number. Since power has to be multiplied at the front, so it becomes 2 by 5 times log of 45. You know how to see log 45. Go to table of logarithms. 45 has 2 digits, 2 minus 1, 1. See 45 under 0. So it turns out to be 1.6532. Just proceed for the calculations yourself. You must get this answer, 0.6613. So this portion represents log of y. But we require only y. So take this log to the right hand side. It would become antilog. That is y is equal to antilog of 0.6613. Again see the antilogarithm table. Your characteristic is now 0. See 0.66 under 1. 0.66 under 1, 4581. Then in the column of 3, 4581 in the column of 3, there is 3 already. So add this 3 here, 4584. 4584. Now where to place decimal? 0 plus 1 is equal to 1. So it becomes 1 digit before decimal. So place decimal after digit 1, first digit. So second question, you must try. So now go for finding the value of 25.57 raised to power 0.21. Again, assume the given number to be y, take logarithm on each side. Again, multiply the power at the beginning, 0.21 times log of 25.57. Number of digits before decimal, 2. So 2 minus 1, 1. 1 point something. Now see in the log table 25 under 5. Then in the last columns under 7, add the 2 to get this number 1.4077. Try to do it yourself. Multiply the 2, you get this answer. Check sidewise whether you are able to do the same. And now since log of y is this much, then y is equal to antilog of 0.2956. Now switch over to antilog table, search 0.29 under 5, then in the last columns under 6, you must get the answer 1975. Now since 0 added with 1 becomes 1, so leave first digit and place the decimal and you get the answer. I hope you have enjoyed the use of tables. So next video to be uploaded is use of trigonometric tables. Thank you very much.